Aren't you tired of all the red CS50 responses? Don't you want to make it all green? Well, I'm here to provide clues to you to do just that. The hardest part for me was to figure out how to find out if the key is a sequence of known repeating alphabets. That is, if, as in this example, H is repeated twice, I must invalidate the key. To do this, I'm going to pass the key, that is argv1, to a function called checkSingle. Now, let us write that function. Inside checkSingle, I'm going to start off by creating an array of ints called count. There'll be 20 such integers inside this. I'm going to write a for loop that loops 26 times. And I'm going to set every character inside the count array to 0. Now, this function accepts the string key as its input and gives an int as its output. We are going to loop through the string key. So int I equal to 0, s equal to still an key, I less than for I less than s, I plus plus. We are going to loop through each character of the string key, and for each character we are going to find the position of these characters within the alphabets. To find the position of each of the characters of the string key within the alphabets, we are going to subtract capital A from string key, and let's store this value in an int called position. Now this will get us the position of key I, provided key I is a capital letter. We need to make our code case insensitive. For that, I'm going to create another variable called alphabet, that is a char, and set it to small letter a. Inside our for loop, we are going to check key I is inside our for loop, we are going to check if key I is an uppercase letter. We are using the isUpper function from the ctype.h library, and if it is an uppercase letter, I want alphabet to be capital A. And here, let's change this to alphabet. After getting the position of each character within the string key, we are going to update the value of count position. That is, let's understand that the count array is going to look like this. So if key I is B, then we are going to update the 0 at the second position as 1. Let's update the 0 at the second position as 1. Now let's make another for loop. This also loops through our count array, and we are going to check if any of the digits within the count array is not equal to 1, then that means that our string consisted of a repeating letter. Let's return false, that is return 0 if count I is found to be not equal to 1, and return 1 if this is never triggered. We are going to return 1, indicating that it is true, indicating that checkSingle is true. That means it is a valid key. The next clue is on how to check if the 26 letter key consists of just alphabets. For this, we are going to use a checkAlpha function. Let's see how it is created. CheckAlpha function also accepts the string key as its input. We have to pass on the value of argv1. Let's loop through each character within this string key, and we have to check if it is not an alphabet. For this, we are using the isAlpha function from ctype.h library. Pass on the value of key.I, and if it is not an alphabet, we are going to return 0. And if it is an alphabet, then this will never be triggered and the function will return 1. You have to understand that return 0 is akin to returning false and returning 1 is akin to returning true. Now let's check if our functions are actually performing well. It's important that you check how your code is functioning, because I've often thought that I completed pieces only to find that they were riddled with errors. So let's check it out. This is the substitution make clues. There is an error. Key contains non-repetitions of alphabets. Why is there an error here? It's just printing F. Oh, because there was no need to pass argv1. There is no need to pass argv1 here. Okay. There is no need to pass argv1 here. Let's do it once more. It's functioning. Let's check clues, and I'll pass on this value, which is invalid. And here, key contains non-repeated sequence of alphabets. Key must contain. I have to change the wording. Key must contain non-repeated sequence of alphabets. Now let's pass on a valid key and see that if it works. This is going to be a valid key. And it works, it's a valid key. Okay, now let's get on with the last clue. Clue 3 is on building the cipher function. Here, this is a function that accepts a string called plain and a string called key as its input. We are going to go through each character within the plain text, then find the alphabetical position of each letter in the plain text. Then we are going to find the letter in the key which is at this position and then print it out. Let me write the code to make it easier for you. First of all, we are going to write a for loop that loops through each character within the plain text. And then we're going to check if it is an alphabet using the alpha function from ctype.h library. If it is not an alphabet, that is, if it is a character which is a space or a punctuation, we can just print this as it is without passing through the cipher. To get the alphabetical position of each character from the plain text, we're going to do what we did earlier in clue number 1. We'll also have to describe a character called alphabet and set it to small letter a. Okay, we're using the same code that we made in clue number 1, where we are subtracting the value of alphabet, that is capital A or small letter a, from the value of plain type. Okay, so now we have the alphabetical position of each character. With this, we have to print out the character at this position inside the key. With this, we have the code to cipher out our plain text. I hope that these clues would be helpful for you, and I'll see you next time with clues for the next problem set. Thank you.